Let's explore PHP Form Security. In this video, you'll learn how to prevent cross-site scripting, that is XSS, cross-site request forgery, which is CSRF, and other form-based attacks. Now let's have a look at some common form vulnerabilities. These include XSS, or cross-site scripting, which involves attacks through form inputs. Next, we have CSRF, or cross-site request forgery exploits. And finally, injection, which includes SQL and command injection attacks. Let's understand cross-site scripting, also known as XSS. XSS involves malicious scripts that are injected into web forms. These scripts execute in other users' browsers, potentially stealing data or hijacking sessions. Here is an example of vulnerable code. Notice the PHP code, which echoes hello, and the user-provided name. An attacker could inject a script tag containing malicious JavaScript such as alert with the message XSS attack. Without proper sanitization, this script will execute in the victim's browser. Here's how to prevent XSS attacks. The key strategy is to always sanitize and escape user input before outputting to HTML. You can use PHP's built-in functions for safe rendering. Here is an example of secure code. We can use the function HTML_specialchars, which converts special characters to HTML entities, preventing the execution of injected code. The parameters passed include the post name, ent_quotes, and the character encoding, which is UTF-8. Alternatively, the function filter_var can be used with the filter_sanitize_string flag to remove or encode potentially harmful characters. Let's understand cross-site request forgery, abbreviated as CSRF. Cross-site request forgery tricks authenticated users into unknowingly executing unwanted actions on web applications where they're logged in. Here's an attack example. Imagine a malicious site containing an image tag that points to a bank's transfer endpoint with the attacker's account and an amount. If a user is logged into their bank account and visits this malicious site, their browser will unknowingly send a request to transfer funds. Let's see how we can prevent CSRF. The key is to use CSRF tokens. Generate unique tokens for each form session and validate them on submission to ensure requests are legitimate. Here's how to implement a CSRF token. First, start a PHP session. Then, generate a random token using bin2hex and random bytes functions and store it in the session. In your form, include a hidden input field named CSRF_token, with the generated token as its value. Let's validate CSRF tokens. Always validate CSRF tokens on form submission to ensure requests originate from your application. On the server side, check if the post request is made. Then, use the #_equals function to compare the token stored in the session with the token submitted in the form. If they don't match, it indicates a CSRF attack, and the script should terminate. If the tokens match, it means the form was submitted legitimately, and you can safely process the form data. Let's talk about SQL Injection Prevention. Form inputs that are directly concatenated into SQL queries can allow attackers to manipulate database operations. Here is an example of vulnerable query. Never directly insert user-provided input into the database query. For example, an attacker could input admin drop table users and double dash. This could allow the attacker to delete the whole users table. Now let's see how we can build safe SQL queries. Use prepared statements with parameter binding to completely prevent SQL injection attacks. With prepared statements, the SQL query structure is defined first, and then the parameters are passed separately. This prevents user input from being interpreted as SQL code. Here's an example of secure implementation. Use the prepare function to create the statement. Then, execute that statement with the parameters being passed as an array. Also, note an alternative of using named parameters. In that case, you specify what the parameter you are passing inside the execute function. Finally, let's go through some security best practices. Firstly, validate all input. Sanitize and validate every form field on both the client and server side. Implement server-side security, which means never trust client-side validation alone. Always verify on the server. Use HTTPS, which means encrypt all form data transmission with SSL/TLS encryption. Finally, monitor and log, which means track suspicious activities and maintain security audit logs. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.